Okay, welcome back. Today we are reviewing for the test. And let's turn our attention to this first problem right here. Now, I hope you know that that's an absolute value function. You should be able to say, yep, that's the V shape. I have that one memorized. If you don't have that one memorized, if I were you right now, I would make a little sketch of the basic ones. Here's what the absolute value looks like. Okay, here's what the squared looks like. And last but not least, the square root graph. Y equals square root of x. That one kind of looks like that. Has a little bit of a curve to it. Okay, so you should have known this is the absolute value graph, but you should have also recognized that a couple things have happened to it. Most people right away are going to recognize that it's upside down. Okay, that one was called a vertical reflect. All right, and then also, I hope you notice that if it had just been flipped upside down, it would have been like down here. It's also been moved up too. Now, knowing that that's what happened to my absolute value, would you please try to write the equation right here for that graph? You can start with the absolute value, but just leave room around it because you have to change it a little bit. There has to be some differences to make it look like this. All right, I'll pause for a second and give you a chance to write that one out. Okay, so here's what I hope you were thinking. I hope you were thinking vertical reflect that's horizontal on the inside. And so that means if it's a vertical reflect, I don't want to put my negative on the inside. I'd want to put it on the outside. By show of hands, how many of you had the negative on the outside? Like, actually raise your hand right now. Okay, so next. Is there something else that has happened to this thing? Yeah, it moved up 2. Then you should have put a plus 2 on the outside right there. So there's my final answer. Y, you could have totally said f of x, that'd have been all right, equals negative on the outside, absolute value of x, plus 2 on the outside also. Both of those things were VOs, vertical changes, and went up and down kind of changes. Okay, this was also a vertical on the outside kind of change. All right, this next, oh wait, we should talk about domain and range. The domain and range on this thing, the domain is always from left to right. If you haven't got that down yet, you should write it down and study it tonight because you got to know domain's left to right. It's about the x's. All right, so this, when you go from left to right, do you get that the graph continues in both directions? So you'd say negative infinity. I could totally be fine if you wrote INF to positive infinity. INF would also work. And you put parentheses around it like this. The range is how low to how high. That is backwards from how we would normally say it. Usually, well, actually, it does depend on the person there. So, but you always say it in math from low to high. All right, what's the lowest that this graph would go? Negative infinity. And what's the highest that this graph would ever go? That spot right there, which is at 2. And you put a bracket. When it touches that spot, you put a bracket. Why don't you put a bracket on infinity? Because you never touch infinity. All right, everybody. Imagine this is your test question, and they say, what's the equation for that one? Don't just say, oh, I know which one that is. Here's the parent function. Yeah, but it's also been flipped and moved. So write the whole equation for it right here. And we'll give you a minute to also do its domain and range. Okay, here's what you should have said. It's a square root graph, so you totally could just start with a square root and just like leave it with lots of empty space to put other stuff in there. And then you think, okay, looks to me like it's been moved to the right. Okay, so that's going to be a -1 on the inside. Now, right, left goes on the inside. Again, if you're worried at all about this test, you can be taking notes right now that would help you a lot. Right and left on the inside. And that might feel like it should be to the left. Understandable, because the stuff on the inside is the opposite of what you would think. And then there's one more thing that happened to this. I hope you noticed that the normal one would be up here like this. This one got flipped, okay? Vertically, up and down, it got flipped over the x-axis. So that's called a vertical reflect. Though vertical on outside, you need a negative right there. Okay. Then your domain for this equation, the domain would be, let me think, has it been, yeah, it's been moved from the original. The domain would used to be like this, but it's been moved over a little bit. Okay, so it's the red one. I'm going to erase just to clean this up here a little bit. Domain of that red one would be from 1 to infinity. Hoping that was an easy one for you guys. 1 to infinity. Now, bracket on the 1. Next, the range. That's how low to how high. Remember, low, high. How low does this function go? It goes to negative infinity. How high does this function go? The highest it ever goes is right there. And how high is that? Oh, a ton of kids are going to say it's 1. Is that really 1 high? No, the highest it goes is that spot, which is 1, 0, 1, 0, and 1, 0 is how high? It's 0 high. Because the y value tells you how high the thing went. Okay, so parentheses on infinities, and it touches 0, so we put a bracket there. Okay, last, let's give you a little time to try this one. What equation do you think that would be? Put it right here, and then figure out the domain and range of that one. All right, so this thing is a square root graph that has been shifted, let me think, up 3. So I'm going to do that first. That's a +3 on the outside. And it's been shifted 1 to the left. So that's +1 on the inside. And it didn't get reflected either left or right. So I don't need any negatives in there. Cool. Now, what if I really wanted to be sure that I had the right answer? Some of you guys are like, but what if I'm not sure if I did it right? You can make an XY chart. And you remember how these work. You put in any number you want, like let's put in a number that we see on the graph, like right here. We put in a -1 for x, and we put it into our function that we think it is. And then I'd get the square root of 0, which is 0, plus 3. 0 plus 3 is 3. -1, 3 was a point on my graph. Cool. My function is working. All right, then domain and range. Domain is how far to the left and how far to the right. Well, the left and right on this thing is from, let's see here, this way, from -1 to, well, it keeps going to infinity on the right. So bracket on the -1, parentheses here. And the range is from how low to how high. And the lowest this thing went was this point right here. And I like to write out the point to help me like make sure I don't make a mistake on that. -1, 3 is that point right there. You know, same one as right there. And so the range is how low to how high. Well, the lowest it went is the y value right here. which is 3. And the highest it goes, keeps going forever, infinity. Bracket on the 3. All right, that's some of the toughest stuff. There's plenty of easy stuff on the test too. Let's talk about some of the easier stuff on the test. What if I said, here's an absolute value graph, or sorry, an equation. What if I just said, I want you to move that thing left 3, and I want you to do a horizontal reflect. You don't have to graph it or anything. That would be much harder. This is just write an equation. If you wanted to take this original parent graph and do this to it, what would the equation be now? It'll always start with y equals, or you could say f of x equals. Let's pause and give you a minute to write that one out. Okay, should have said absolute value of x, but left 3. Notice I left myself plenty of room around the x. Left 3, boy, it feels like it should be minus 3, but it's actually plus 3. Remember, it does the opposite of what you'd expect inside. And then horizontal reflect, well, it's high vo. Horizontal on the inside, vertical if on the outside, and this is a horizontal, so the negative goes on the inside. Now this one is a particularly tricky one. We try to avoid doing double changes on the inside because it's better if you have parentheses than if it's like that. So that you would want the parentheses there to do that one properly. Okay, let's do one more easy one. If I give you a equation that's got a couple changes, that's just easier changes, 2 x minus 4 squared plus 1. Tell me the 3 things that happened. Pause for a second while you give that a try. So I hope that you said there was, and we're not going to force you to do it in a certain order. Right 4. This one here is up 1. And last but not least, is that a vertical or a horizontal? I hope I've done this enough, so let's stick it in your head. Horizontal on the inside, vertical on the outside. That's a vertical, and it's a stretch when the number's a whole number. When the number is a fraction, then it would be a shrink. All right, we had one where the question was kind of weird in a previous video, and I had a question like this, something like that. If the question was actually wrong, because the question said something about how we did a horizontal stretch with a factor of 4. This would not make sense because we don't say stretch when we're actually going to shrink it. This would be a shrink. Why? Because that 4 there, that 4 feels like it would be a stretch, and it is definitely horizontal. It feels like it would be a stretch 4 times bigger, but no. On the inside, they do the opposite of what you would think. And so that would be a horizontal shrink with a factor. And this is where they got it wrong. They said it was a factor of 4 on the problem that I was trying to do. But you actually should say that that was a shrink factor of 1/4. Remember, you're going to do the opposite of what it looks like. It seems like you would multiply everything by 4, but the shrink factor would be said to be 1/4. All right, so now let's just get a few points that are on this graph. XY chart, it's the most basic thing. You got to be able to find a few points. Now, I can't be psychic and know which ones you're going to pick, but try to make the thing inside equal 0 and then use other numbers that are around that. So to make the inside equal 0, I can use 0, of course. I could also use like -1 and maybe +1. Everybody try those three and see what you get when you stick in -1, 0, and 1. I'll pause for a second while you give that one a try. Okay, when you stuck in -1, you should have had 4 times -1, which makes -4, and you should have gone square root of -4. That doesn't exist. Okay, there's a lot of ways to say that. DNE does not exist, or no, not real, maybe would be another way to say it. I would have accepted NA. I would have accepted a 0 with a slash through it. There's a lot of ways you could say, hey, that doesn't exist, Mr. Server. Now, how about if you put in a 0? If I put in a 0 here, then it's 4 times 0 is 0. Square root of 0 is 0. Sometimes people feel like 0 doesn't exist, but it does. And last but not least, if I put in a 1, put in a 1 right there. 4 times 1 is 4. Square root of 4 is 2. And there's 3 points, just kind of the beginning of a graph. We'll do more graphs in a minute here. Okay, let's move on to the next page. Here is a typical hard graphing question. And just to make sure that it's easier for us to like grade yours, on the test, you'd be able to put in any numbers you wanted to. Okay, but I'm going to ask you to specifically put in -2. Why am I choosing numbers like that? Because I know I'm going to have to cut it in half first. And then I'm going to square it. And then I'm going to subtract 2. And I basically want the numbers to work out nice. Let's everybody put in, well, boy, 1 wouldn't really work that well because then I have to have a 1/2 and I have to square it. So I don't want to use a 1. Let's go with 0. 0 will work pretty good. Now let's put in 2 and let's put in 4. Seems like some decent points. Everybody find it what you get if you put in -2, 0, 2, and 4. Pause for a minute while you try that. All right, so when you put in -2, I have 1/2 of -2 is -1. I square the -1 and I get 1. Hope you get -1 squared would equal 1. And then I got to subtract 2 from it. Don't forget the ending. So I had -1 squared, which is 1. 1 minus 2 is -1. Putting in 0 is a lot easier because then when I put the 0 here, everything inside there just turns into 0. 0 minus 2 is -2. Now when I put a 2 in here, I have 1/2 of 2 is 1. 1 squared is 1. 1 minus 2 is -1. And then when I put in a 4, put in a 4 there. 1/2 of 4 is 2. 2 squared is 4. 4 minus 2 is 2. And then you just have to graph these points. Easy peasy once you get to the graphing part. Okay, -2, -1, 0, comma, -2, 2, comma, -1, and 4, comma, 2. What you have here, this is just a rough sketch, you have a parabola that's been shifted down a couple and has been made wider. Do you get that that's a parabola? I know I made it kind of look more V-shaped, but it's actually a curve. It's a U-shape parabola that's been made wider because of that, and it's moved down because of that. All right. Now everybody try without any advice from me. Put in some numbers. See what you get for the graph of this one. Okay, I'm going to put in -2, -1, 0, 1, and 2. And that should cover most of the things that people picked. Maybe not all of them. That's okay. On the test, I'll have to grade each individual point that you picked. So if I put in -2, I'd get 2 times -2 is -4. Absolute value of that is 4. Negative on the outside brings it back to -4. I want to do that one out slowly just to make sure you totally get what I did there. Negative, absolute value, 2 times -2 And the first thing I did was this part, and I made it -4. And you might be thinking, but the absolute value of that is positive, Mr. Server. Yes, it is, +4, but then you have another negative on the outside, and that makes it back to -4. Okay, now if I put in -1, I'm going to go a little faster on these. If I put in -1 here, then that's going to be -2. Absolute value of that is 2. Comes out negative though, -2. Put in a 0, and even though the answer is 0, it's -0, which is still 0. When I put in a 1, I get 2 times 1 is 2. Absolute value of that is 2, but make it a negative because there's a negative on the outside, -2. And last of all, put in a 2, and you get -4. Okay, final graphing of this, -2, comma -4, and -1, -2, and 0, 0, and let me think, 1 comma -2, and 2 comma -4. Well, it looks like it's an upside down V, and that makes sense because this is a negative on the outside, so it vertically flipped my V. And then what's this 2 supposed to be doing? You'd think it would make it wider. It's actually narrower than it would have been. So let me show you. Here's my final answer right here. And if you'd have done a normal V, it's subtle difference, but the normal V would have been like that. So it is narrower, the red one, the actual answer, is narrower than the other one because of the 2 on the inside. All right. Boy, this is so important. I'm going to put in another slide to remind you again. It's horizontal on the inside. So that's a horizontal change. And this would not make it twice horizontally. It would make it half as big as it used to be. Okay. The 4 on the outside, that's a vertical on the outside. And that one you trust. And so that one would be a 4 times bigger vertically. All right. This next part, I'm just going to see if you can write the equation. Given here's the parent graph, which you should know is y equals the square root of x. Can you tell me what the equation for this one would be? Kind of looks a little crazy. I hope you can figure out what equation should we write for that graph. We can look exactly what happened to the points. Yes, you've seen this one before, but I still think it's a good practice problem. Okay, so you might have just thought it was moved up, but it wasn't. It was stretched up. How can I tell? Because it still goes through 0, 0, and that point never changed. If I had moved it up, okay, that would have been like a change on the outside, like, you know, everything moved up 3 or whatever. That's what a move up would look like, but that's not what happened here. This was a stretch up. And so there's a number on the outside, and I'm hoping that you knew that if you compare these numbers, 1 and the 5, and the 2 and the 10, and the 3 and the 15, you can see they're all 5 times bigger. There we go. There's our equation. How about this one? You should know what the parent graph is, and then you should be able to tell what the transformed graph would be. Definitely a tricky one. It's like almost like R4 level tricky, but do your best. We'll pause for a second, give you a try. Okay, parent graph, absolute value of x. Really ought to know that one. That's like super easy. Okay, but if you don't have them memorized, I guess it isn't super easy. Memorize the key ones. I started with that at the beginning of the hour. Now this transformed one. You can tell it wasn't moved up. You know why? Because 0, 0 is still there. It wasn't moved down or up or left or right. So how was it changed? Well, it's still absolute value of x, but it's not been moved left or right or up or down. What's left? Some kind of a stretch. Okay? And there's actually 2 ways you could do this one. I'm going to think of this as, boy, it got wider. It got a lot wider. And we're just going to do it that way. Just in case you did it the other way, I'll show the other option answer. But If I think of this as this thing got a lot wider than it used to be, then that's a horizontal on the inside kind of thing. So then, if I'm going to do it that way, I would say how much wider did it get? Well, it normally would be go through 1, 1, but this went through 4, 1. That means it got 4 times wider, and I bet there's some kid who's going to put a 4 right there, but it's a 1/4. Okay, that made it 1/4 as, seems like 1/4 as wide. It's actually 4 times wider than the V used to be. Now, if you want to do it the other way, some people are going to say, I thought of it as being vertically squished. Like that got squished down and it got 1/4 as tall. And actually that would work. So if you did this, that would have also been correct. All right, one more. If there's one thing there's a lot of on the test, it's graphing. Okay, and so you got to get good at graphing. So I'd like you to give you this one. We'll pause for a minute. We have one last problem that you need to be able to do without any help, and then I'll show you the answer in a minute. All right. Appreciate how you've been hanging in with me here. This is a lot of stuff. This is not an easy test, and this has been a long lesson. I'm glad you're still with me. So I'm going to put in a -2, a -1, a 0, and a 1. And I'm going to say, it depends on the test how many points you have to make. It'll say in the problems. But let's just do those 4. So if I put it, well, what the heck, we'll put in one more. We'll put in a 5th point, because I think a lot of times they're going to want 5 points. So, all right, so if I put in -2, the -2 goes in here. And to speed this up, I'm going to just do the first one with you, and then I'm going to pause and then write the rest of them in. So I'm going to put the -2 plus 1, and I'll have -1. I square that. -1 squared is 1. Times it by 3 is 3. Plus 2 makes 5. Again, if you write this out, 3 parentheses, -2 plus 1 parentheses, squared plus 2. That was me putting this -2 in the equation. You have to be able to crunch numbers like this. They're all nice, easy numbers, but there's no calculator allowed in the test. So this one would make -1. I squared it, made 1, times it by 3 is 3, plus 2 makes 5. All right. Okay, so here's the points that you should have gotten. You'll probably notice that some of them go off of our graph. Here's one of my points. -1, 2 is right there. Over 0 up, 1, 2, 3, 4, 5 goes right there. And doesn't this look like a stretched parabola that's been moved 1 to the left and up a couple? That's what it looks like to me. All right, so if I graph the rest of them, they're going to go off the screen, and I totally get. You might be like, well, how am I supposed to do that if it's on the test? We know. We looked at the test and made sure that there'd be enough room on the test to be able to graph enough points that we ask for. So like if we're asked for, in this case, we could have only asked you for 3 points. Now, maybe in the real test, we would have moved it down or something so that you could get lots of points in if we move the graph down and to the left. But you'll end up having to go, okay, well, I guess I've only got 3 points on there, so I'd have to like try to add more points to it. But we can see that our graph, it goes off the graph here, so trying to add more now wouldn't work. But if we had made it more like this, you'd have been able to get a lot more points if we'd have moved it down. So again, the most we'll ever ask you for is 5 points. All right, one last kind of problem. So if we gave you this list of parent points and this list of the points that they've been transformed to, you'd have to be able to say what happened to this graph. So my best advice on this is to just graph it. Okay, and we will provide you with some graph paper to graph it. After you've graphed this, and I understand right this second you don't have graph paper, but it shouldn't be too hard for you to make a sketch of this, and even just a sketch will kind of give you the idea of which way this thing got moved. All right, so everybody try to sketch the original one and then the new one that's been moved. Pause for a second while you do that. All right, so I hope you realized that what we had here was a parabola. And it was your classic normal parabola, looked like that. Then I'll do in blue the transformed points. And if I just graph those, 0, 3, and over 1 up 0, and over 2 and down 1, over 3 up 0, over 4 up 3. It's maybe only at the very end where you go, oh, I see, it's a blue parabola that's been shifted which way compared to the red one? Well, it went down 1 and it went over a few. Well, how could we have known that by looking at our points? Do you get this compared to this? Means that it went, the x got 2 bigger, and here the x got 2 bigger, and here the x got 2 bigger, and here the x got 2 bigger. I get the points over the x got 2 bigger. So what's the equation? Y equals x, and it seems like you should say plus 2 on the inside, but you shouldn't. You should say minus 2. What? Well, because look at it. It moved to the right 2. That's how we do right 2. Can't trust the stuff on the inside. It seems like it should be plus 2. Actually isn't. And then I'm going to say this is a parabola, so it's got to be squared. You know, the normal graph would have been y equals x squared. And one last thing. It has also been moved to the right 2 and down 1. Minus 1, just like it seems like. Why are the stuff on the outside so easy? Because you can trust it. Now, if you're struggling with, like, if I got the right equation, remember what I did last time? I checked it. I actually tried some points, and if I put in 0, I'm supposed to get 3. Do I really get 3 if I put in 0? Put in a 0, I get negative 2 squared, which is 4. 4 minus the 1 makes 3. It's working. And if I put in 1, I would really get 0. I'll double check. I put in a 1 here. 1 minus 2 is negative 1 squared is 1 minus 1. 1 minus 1 is 0. It's working. Okay, so I know that was the right equation right there. Okay, now you've got a review sheet, probably the most important homework that I've assigned you because this is a challenging test. And as you know, I've been gone. And so this homework tonight, do it and check it with the answers that are posted. And I'll put a Dropbox for it. And I'm telling you, this one is super important. It's definitely going in your grade. All right, that's all I've got for you for today. Good luck as you take the test tomorrow.